Alright, this is the introduction for the momentum and collision lab, and what we know is that for all collisions, momentum is conserved in the absence of external forces. For elastic collisions, both momentum and energy is conserved, and in inelastic collisions, only momentum is conserved, and energy is not a conserved quantity, and that's what this lab is going to show you. So what we're going to do is we're going to go ahead and have a collision where we're going to have two boxes, and we're going to have box A and box B, and these guys are going to be colliding with one another. And kind of what we're going to see is that the momentum beforehand, don't forget momentum is a vector quantity, is equal to the momentum afterwards. Technically, I have you calculate the ratio of the momentums. So what we can kind of do is we can say we have the mass of A, the velocity of A initially, plus the mass of B, the velocity of B initially. These guys are vector quantities, so positive and negatives do matter. That's going to be equal to the mass of A times the velocity of A afterwards, plus the mass of B times the velocity of B afterwards. So what we're going to do is you're going to go ahead and pop open the simulation. So let's go ahead and do that really quickly. And there we go. So if I've gone ahead and I've popped open the simulation. Now what I'm going to have you do is I'm going to have you very first uncheck those two boxes. They're useful, but they're kind of distracting. And the first thing I'm going to have you do is I'm going to have you take this slider right here, and you're going to turn this up to perfectly elastic. I'm going to have you mess around with these guys. You can go ahead and just enter things directly in, so you can go ahead and enter that guy in. And I'm not going to mess around with these. All you're going to do is you're going to record the initial velocity and the initial mass of the red block. You're going to record the initial velocity and the mass of the blue box, and then you're just going to go ahead and allow these guys to collide, and then go ahead and hit the pause button, and then you can go ahead and record the final velocity and the final velocity. Now, technically, you can also record these, although I do want you to, show me the calculation for them, so that way you can show me that you actually know what's going on here. All you're going to do is you're going to record the initial velocity and final velocity, initial velocity and final velocity. I'm going to have you make the blue box move towards the red box, do the same thing, record the velocity, and then I'm going to have you mess around with the mass of the blue box, so record the velocity and record the velocity. Now all you're going to do is you're going to calculate the momentum beforehand. I do want you to show me a sample calculation of each. I know you can just read it right off the simulation. And then I'm going to have you calculate the momentum of the system, where essentially all you're going to do is you're going to add the momentum of box number 1 before to the momentum of box number 2. You're going to do the same afterwards. You're going to calculate the momentum of the system, just add this to this, and then you take the ratio. This ratio is going to be close to 1, and since this is a simulation, it's going to be perfectly 1 within your ability to round. What that means is momentum was probably conserved. I'm going to have you go down, and I'm going to have you calculate the energy before, 1/2 mv squared, 1/2 mv squared, and add those guys together. Now you have the energy beforehand, 1/2 mv squared, 1/2 mv squared, add them together, take the ratio. If this ratio is close to 1, and if it's not, you better be scratching your head, then energy was conserved. Then I'm just going to have you go ahead and take that collision slider and move it down to the inelastic and do the same exact thing for the inelastic collisions. So same exact measurements and the same exact calculations.